Happy Wednesday. So today we're going to be talking about the conservation of energy. Basically, we're going to do a shortened version of a test review. Okay, so tomorrow, Thursday, will be your test. We'll talk about how the test has changed a bit since we're doing it online. We're just going to review some of the homework questions that you might have. All the answers to the conservation of energy and momentum worksheet are in Google Classroom. And all of the answers to the energy test review are in Google Classroom. So if you did not check those out on Friday, please make sure that you go and do that. We talked about any questions we had with the first two sets of textbook problems in class. So I'm going to talk about the last set of textbook problems in this PowerPoint. Okay, so let's get started. So we talked about two different types of energy. Specifically, we calculated two different types. First type being kinetic energy. So again, the kinetic energy of an object is the energy due to its velocity. Okay, so any object that is moving has kinetic energy. Kinetic energy is equal to half of the object's mass times its velocity squared. And kinetic energy is measured in joules. Again, an object can only have kinetic energy if the object is moving. The other type of energy that we talked about in this unit was gravitational potential energy, which is due to an object's position, usually to ground, okay, but by some reference point. Okay, and the equation for that we know is mass times the gravitational constant, which is 9.8 meters per second squared, times its height above some reference point. Okay, so energy, types of energy together, okay, we know that they can be conserved. We talked about the conservation of two different types of energy. So we said that conservation of energy was, okay, you learned in chemistry that energy can never be created or destroyed. Our physics definition is a little bit different. Okay, it says that the total energy in a closed system must remain constant. So that means that energy types can be transferred from type to type, but the total, the sum of the energy will be constant. And that equation that we came up with, right, the sum of the initial energy must be equal to the sum of the final energies in the system. Okay, types of energy, we have kinetic energy initial plus gravitational potential energy initial must equal the final kinetic energy of the object or system plus the final gravitational kinetic energy, the final gravitational potential energy of the system plus any energy that is expelled as thermal energy. Okay, which really only occurs if there's friction or air resistance involved. And if friction or air resistance is not involved, heat is equal to zero. If heat is equal to zero, meaning that there is no friction, we can say that the mechanical energy in the system is conserved. Okay, so let's talk a little bit about what mechanical energy is again. Okay, so the conservation of mechanical energy states that in the absence of friction, the total kinetic and potential energy of a system is conserved. So that means that the kinetic plus the gravitational potential must be constant, and we call that sum mechanical energy. Okay, so if a problem tells us that there's a frictionless surface, or that there's no air resistance, okay, or doesn't tell us anything about mu, we assume that mechanical energy is conserved, and that heat would be equal to zero. Unless the problem asks us to determine if kinetic energy is conserved, we pretend that there's no heat. Okay, so let's take a look at a question from the second homework. So in your textbook, which you should all have one of those at your house, Okay, on the first day of school, you are told to bring it home, to leave it home, and to make sure it stays home. Okay, so if you'd like to follow along on page 175 in the textbook, number 73, the problem is on the slide as well. So a skier coasts down a very smooth 10-meter high slope, similar to the one shown in the figure. Okay, so that figure is up there on the screen for you. If the speed of the skier on the top of the slope is 5 meters per second, what is his speed at the bottom of the slope? Okay, the answer in the book is 15 meters per second. Okay, but let's talk about how we get to that. And again, this is similar to an example that we did in class. We named the skier Christy, okay, but very similar to that problem. So notice that we're not given mass. If you remember, mass cancels out, okay, because it's present on both sides of the equation. So you don't actually need the mass of the skier, okay, but notice that they don't give it to us. We are told that at the top of the hill, V initial is 5 meters per second, okay, and the hill is 10 meters off the ground. So that means that our skier is starting with both kinetic and gravitational potential energy. The skier then moves down the slope, the very smooth slope. Very smooth would imply that there's no friction. So there's no friction on the slope. When the skier reaches the bottom of the slope, we know the height would be 0. Okay, they don't give us a height, so we assume that that's the reference point. We assume that the height at that moment is 0. We need to figure out what the final velocity is, or the speed. Okay, right? So, we use the conservation of energy to determine that. So we know at the top, he has both kinetic and potential. At the bottom, he has only kinetic. So that means the sum of the initial energy must equal the sum of the final. So his initial kinetic energy plus his initial gravitational potential energy must equal his final kinetic energy plus final gravitational potential plus heat. Okay, again, very smooth tells us that heat is 0. So we can cross that right out of our equation. We know that the final height is 0, so we can cross potential energy, final, out of the equation. Right? Mass times 9.8 times 0 will give us 0. Okay, we will have, however, initial kinetic energy, potential energy, and final kinetic energy. So we cannot cross those out of the equation. So we'll fill in what we know. Okay, so we know that kinetic energy is 1/2 m times the initial velocity squared plus initial gravitational potential, which is m times g times the initial height, must equal 1/2 times the object's mass times final velocity squared. We don't know mass, so we're going to leave that as a variable. I'm going to plug in everything else that we know from our diagram in the corner. Okay, so we have mass, which we factor out of both terms in the equation. So m times the quantity, 1/2 v1 initial squared plus g times the height, must be equal to, if you factor out an m again over here on the second side, m times 1/2 times the final velocity squared. If we divide both sides of the equation by m, the m's will cancel out. Okay, mass does not actually affect the amount of energy in this case because there's no friction. So the mass would cancel out of both sides of the equation once we divide both sides by m. Next step would be to plug in those initial velocity and height values, and then we're going to simplify. Okay, so 5 squared, we get 25, half of 25, we get 12.5. So units are meters squared per second squared. Okay, and 9.8 times 10, we get 98 meters squared per second squared. The right side of the equation there would stay the same. Okay, so our job is to simplify and get v final by itself. So I'm going to add 12.5 plus 98, we get 110.5, Okay, and then to get v final by itself and multiply both sides by 2, the 1/2 cancels on the right-hand side. Okay, on the left-hand side, we get 221 meters squared per second squared. To get v final by itself, we must take the square root of both sides of the equation, and we will get 14.87, okay, which rounds to 15 meters per second. So that's the final velocity of the skier when they reach the bottom of the slope. Okay, so that was number 73 on your homework. Okay, so let's continue. So our third set of homework, our third and final set of homework, we had textbook problems, 61, 62, 64, 65, and 70. Okay, so we're going to start out with number 61. So again, the questions are there on the screen for you, but you can follow along on page 214 if you would like to. So number 61 asks, which of the following is not conserved in an inelastic collision? A, momentum, B, mass, C, kinetic energy, or D, total energy? Okay, so looking at those choices, momentum, we know, is always conserved in all collisions, so that cannot be the answer. Total energy is conserved throughout the entire universe, right? So that can also not be the answer. Momentum and total energy are always conserved. So our choices are mass and kinetic energy. Technically, in an inelastic collision, we know that the objects collide and they stick together. So the mass present in the system before is equal to the mass present in the system after. Okay, the objects actually stick together and become one big massive object. So we know that mass is conserved. Okay, so the answer has to be C. Okay, but we also know that kinetic energy is not conserved the kinetic energy is not conserved in an inelastic collision because it takes a significant amount of thermal energy to cause two objects to stick together and continue to move together. Okay, so kinetic energy is transferred to thermal energy during the collision. So therefore, in an inelastic collision, when the objects stick together, thermal energy is created, so kinetic energy cannot be conserved. Okay. Number 62. In a head-on elastic collision, M1 strikes a stationary mass M2. There is a complete transfer of energy if, okay, our options are A, M1 is equal to M2, so the masses of the objects are the same. B, M1 is a lot greater than the mass of object 2. Choice C is that mass 1 is significantly smaller than mass 2. And our last option is that the masses would stick together. So the word head-on elastic collision, D is not the answer, right? Elastic means the objects have their own independent velocity after the collision. Therefore, that can't be the answer. D cannot be the answer. Objects cannot stick together if they have independent velocities. That would mean that they have the same velocity. So we can eliminate D immediately. If you think about your lab, right? So actually I have this quick video down here on the screen. I'm going to click play. So the cards are roughly the same mass. They're not exactly the same mass, but roughly the same mass. So 0.271 kilograms and 0.268 kilograms. So they're basically the same mass. When they collide, okay, because they have the same mass, the momentum is completely transferred, right? Because they have the same mass, they have almost the same velocity. So in order for energy to be transferred, right, for the amount of kinetic energy to be directly transferred, they must have the same mass in order to gain equivalent velocities before versus after, right? So if M2 starts at a velocity of 0 and M1 starts at a velocity of 1, in order for M2 to have a velocity of 1 after the collision and M1 to have a velocity of 0, they must have the same mass. So the answer choice there is A. M1 must be equal to M2 for all of the kinetic energy to transfer. Okay, so let's take a look at 64. So 64 says, discuss the common and different characteristics of an elastic and an inelastic collision. So I actually asked you that question on your energy test review. Okay, so if you haven't looked at these yet, they are in Classroom. They were posted on March 12th. The full answers to both the test review and the homework, that worksheet, that yellow worksheet with the 4 problems, was called Energy and Momentum Practice. All of that work is in Google Classroom, so please check that out. Okay, so number 64 is actually also on that study guide. So I have the answer up here on the screen, the same one that's in the document in Google Classroom. So just take a minute, double check for 64 that you have those main points that are listed on the screen. Okay, and the main point there, right, is that momentum is conserved in both collisions, but kinetic energy is only conserved in perfectly elastic collisions. Okay, and perfectly elastic, again, means, okay, if you're in person, I'd ask you this, but what it means is that kinetic energy is conserved, and that no object suffers a permanent deformity after the collision. Okay, 65. If a rubber ball hits a wall and bounces back with the same speed, is the collision elastic or inelastic? Okay, so inelastic would mean that the ball and the wall have the same velocity after the collision. They'd have to stick together. Okay, that obviously does not happen based on the problem, so the only collision it could be would be an elastic collision. Okay, the ball and the wall have independent velocities after the collision, therefore it has to be an elastic collision. Okay, and you'll notice here, on the board, number 70 was assigned. Can you see I have a little strikeout on the screen here? So technically number 70 was assigned for homework. There is a typo in the textbook. Okay, so you do not have to do number 70. Number 70 is an optional problem. Because there's a typo, there's actually 2 different ways that the problem can be interpreted. So I'm going to talk about the problem for those of you who did do the problem and are confused. I'll talk about both ways in which you could have approached the problem based on the typo. Okay, but because there's a typo, you do not have to submit that question when you upload your homework. Okay, so number 70 states, and again, this is on page 214 in your textbook, 2 balls with mass 2 kilograms and 6 kilograms travel toward each other at speeds of 12 meters per second and 4 meters per second, respectively. Okay, so that means that the 2 kilogram object is moving 12 meters per second, and the 6 kilogram object must be moving at negative 4 meters per second in order for them to collide. Right? They must be moving in opposite directions in order for a collision to occur. Okay, so far so good. If the balls have a head-on inelastic collision, and when a 2 kilogram ball recoils with a speed of 8 meters per second. Okay, so we're going to stop there for a second. In reading that statement, right, you cannot have an inelastic collision if the object recoils, right? A recoil would mean that it moves in the opposite direction. So when they collide, and one object would move opposite relative to the other. Okay, an inelastic collision is when they collide and move together. So that statement basically references two different collisions, term after term. So you either have to, okay, treat it like an inelastic collision or treat it like an elastic collision based on the word recoil. Technically, the book wanted it to be an elastic collision, meaning that the objects move at different velocities after the collision. Okay, but again, due to the typo, you can approach it two different ways. What they want to know is how much kinetic energy is lost in the collision. Okay, so you want to be finding heat, basically. So find kinetic energy before and after the collision, subtract the two to figure out how much is lost. So I'm just going to show you both ways in which you could have approached it based on the typo. If you have any additional questions with this problem, you can stop by after school and join the Google Hangout. You have an invitation sent to your email. Okay, so if you still have questions with 7D after this, you can come to that Google Hangout. So one way that you could have approached it would be that it's an elastic collision. Okay, so if it's an elastic collision, that means that you're missing the final velocity of object 2. So your first step would be to use the conservation of momentum in order to find that missing final velocity. Okay, you must be very careful with the signs. Okay, so using conservation of momentum, you see the work down here on the bottom of the screen next to number 1. You would find that the final velocity of the second object would be 2.67 meters per second. Using that velocity, that you could then plug into the conservation of energy to determine that about 100 joules of kinetic energy would be transferred to thermal energy, or heat. What would this mean? This means, right, if it's an elastic collision and there's thermal energy, that means that it's not a perfectly elastic collision. That means that one or more of the objects are deformed after the collision. Okay, the second way in which you could have approached it would be to treat it like an inelastic collision, which is stated in the problem. If you treat it like an inelastic collision, that means that both object 1 and 2 have the same velocity after the collision. Okay, so you'd add the masses, multiply by that velocity, that final velocity of 8 meters per second squared, and then determine that 64 joules of energy were lost in the collision. So again, this problem is not mandatory. You do not have to do number 70. If you did do number 70, there were two ways that you could have approached it, either as elastic or inelastic, due to that typo. Okay, if you have any other homework questions, you can ask today after school at the Google Hangout. To answer some general questions that I received, I'm just going to talk briefly about how things are set up in classroom. Okay, and then I'll get on to your test. So every Monday, your weekly learning plan will be posted. It'll give you the general overview for what will occur that day, what the assignments will be called, and when they're due. Okay, so your weekly plan will be posted every Monday. Every day during your class period on Google Classroom, the specific daily assignment will be posted. So on Tuesday, your Tuesday assignment will be posted. Okay, today, Wednesday, the Conservation of Energy Momentum Test assignment is posted. Okay? So again, daily assignments are posted every morning or afternoon during your class, sometimes a little bit earlier. Your weekly outline is posted every Monday. Okay, everything will be submitted through Google Classroom. You'll notice that as of this morning, about 11 a.m., your Friday assignment was altered. Okay, so the Explosions Energy and Collision Lab, which if you're in period D, right, is technically due Wednesday. If you're in period G, it's technically due Thursday. Everyone will submit their Explosions Energy and Collisions Lab to Google Classroom on Friday. So if you're in period D or G, you will take a picture of your lab. If you did not physically submit it via paper before we left, you'll take a picture and post it to Classroom. If you're in period I, you should have collected data on Friday with a substitute. Okay, it appears that not everyone collected data. So if you are in the boat of not collecting data with a substitute on Friday, the data is posted for you in Classroom. You will do the calculations, fill out the Google form in Classroom, and submit it. So everyone on Friday will attach their lab to the Friday assignment and submit it. Okay, if you have any issues with that, please contact me. If you handed your paper in physically before you left, I have it and will grade it accordingly. Okay, so if there are any questions, you can add it to the Google form for today, you can email me, or you can go to the Google Hangout. Okay, I'm going to briefly discuss what your test is going to look like for tomorrow. Okay, so your test is still going to be the same 3 sections. You'll have multiple choice, open-ended, and then some problems to solve. So you have 11 multiple choice questions. You will choose the best answer choice. Okay, so whichever value is closest to the answer on your calculator is the one that you will choose. Okay, the answers won't necessarily be exact. Okay, you have to round and pick the best answer choice. Okay, you're open-ended. There will be 3 conceptual questions. Again, they're based on your DNOws and the study guide. You will explain in full sentences. So you will answer those 3 conceptual questions in full sentences. These directions will also be on your test. Okay, your open-ended, which is mathematical, is 1 question. It has multiple parts so that I can give partial credit. Okay, so what I mean by that is part A could be identify the initial velocity of this object. So basically, you're identifying the givens in part A, B, and C. Okay, part B, A, B, and C will be identify the givens. So I'm going to point each for that. Part D could be identify the equation needed to solve. So you'll have a list of equations to pick from. You have to choose the equation that you would use to solve. Next part would be to calculate. Okay, so choosing the equation is 1 point, the calculation is 2 points. Okay, so therefore, if you make an algebra mistake, you'd only lose 2 points. That way, I can still give you partial credit. Okay, so calculate the amount of kinetic energy present in the system before you would type in blank joules. Okay, next question would be calculate the amount of kinetic energy after in the system. You would type in blank joules. Okay, then you would answer based on those two previous answers if kinetic energy is conserved in the collision. Okay, so that one open-ended will have multiple parts from A to G, all the way from identifying the givens to identifying the equation to giving me what your answer is. Okay, you will not submit work, but you must answer each part of the question. Each part of the question is worth partial points. That way I can give everyone partial credit if your answer is incorrect, but you have the correct equations, the correct givens, etc. Again, if you have any questions with that, you can ask in a Google forum or at the Google Hangout after school today. Okay, if you, for some reason, lost your note card, okay, there is an emergency list of equations here on the slide for momentum and energy. Due to our situation, okay, you are allowed to use your notes, your homework, your calculator, your note card, and your textbook to complete the test. Please do not use the internet, okay, but you can use any resource that was given to you, aka your notes, homework, textbook, on your actual test. I will put a print version of this in Classroom that you can print out, okay, if you don't have your note card with you at home. Okay, so tomorrow, that's linked in Classroom. Tomorrow, during your class period, an assignment will pop up. You will click the link to the Google form. Your test will be in the Google form. You will fill out and submit the Google form, and that is your test. It will open during your class period, and it will close by 2:30 p.m. So you must complete the Google form during your class period tomorrow, Thursday. Okay, if you have any questions, please let me know. Enjoy the rest of your day. And I'll see you guys